Hello everyone, welcome to attend today's training. Today's training is about wiring module of our Wecon products. Uh, our products provides two modes of wiring mode. One is expansion module, and the other is LCM module, which support to communicate with PLC by Modbus protocol. Okay, let's take a look of the expansion module. For expansion module, we have more than one expansion wiring module. LX3V2WT is one of them. It means it have two channels for the load cell. And if we also have LX3V1WT, it means we can only just connect one load cell. And even for the two channel within module, it have some slight difference. As you can see in our Wecon support center, we have 2WT, 2WTG, and 2WTL. 2WT, the resolution is 24 bits, and for 2WTL, or 2WL, it have a little difference about the resolution. The resolution is 18 bits for 2WL. And for 2WTG, it has the same functions of 2WT, but it also adds some functions of flow calculations, which can be used in grammage system. This is the appearance of our wiring module. Actually, it looks very similar to the expansion module we introduced before. And it also have the built-in communication cable and the expansion module interface to connect another module. And this part is for the LED detector to show the states. Link LED shows the communication between the PLC and the module. And the COM LED shows the data communication. WT LED shows the range of the input, and the WE LED shows the result of the calibration. As you can see it here, now I connect one LX to WT here. So as you can see, now the link LED is pink. And there is a slight different. And this part is WT LED here. Not very clear. But as you can see now is the normal state of the channel 1. when the input range is within the range, so it always on. And for the channel one with calibration is succeed for, so it's off here. These two LEDs for the channel one. And for channel two here, because I didn't use it before, so I didn't make the calibration. So the channel two is always off. And it's always on. It's always on. And for the WT LED is always flash. Okay, let's move on to the wiring. So in today's training, I use the 4-wide road cell. So as you can see here, we need to connect E1 positive to the corresponding terminals. And we also need to shortcut to E1 plus and to F1 plus, and shortcut of E1 negative to F1 negative. For the rest wiring, it just connect corresponding terminals. And if you use a 6-wide load cell, there is no need to shortcut any terminal. Just connect as the cable determination. And we also need to connect DC 24-volt power supply to our module, both of them. And this is some key buffer memories of LX3V2WT. As you can see here, we need to this module support to read the gross weight and the net weight, and it supports to make a calibration. And we can also modify the sampling frequency and get the state code. Let's see this example program here. The first is when we use this module at the first time, we need to calibrating weight. So at first, we cannot put any weight on the load cell. And then we write K1 to the BFM8. And then we add a standing weight to the load and write the weight in D2 here, register D2. It can be any other different registers. And write it to the BFM23. BFM23 here. is the weight value for calibration. Because here we use channel 1. If you use channel 2, you need to write different BFM. You need to write it to BFM 63. And after that, still put on the sender weight on the load cell and write K2 to the BFM 8. After that, we finish the calibration. And then when we put another object on the load cell, we can read the weight from a BFM. BFM 16. As you can see, the average weight, and because it occupied two word address, so for here, the length of the data we read is K2, two address here. We can see this video. For example, at first, I didn't put any objects on the load cell. And I put a V box here on the load cell. It weighs 0.3 kilogram. So I put it on the load cell. And then we write it 300 gram. And then enable M1. After it enabled, it reset. And then we trigger M2 here to finish the calibration and reset M2. And now we can get the weight value. And then I put another box. It gets another value. And it's about 0.26 kilogram. And we get a value 256. Okay, this is about how to make the calibration and get the weight value from our LX3V2WT. Do you have any questions about this part?
No, I have no questions. Thanks.
Okay, let's move to another part. Another part is about to display the net weight and the gross weight. Because sometimes we have some package to weight with our products. So we need to set the tail weight and the gross weight. Let's see this example. The first, we need to put our package to the node cell and set the tail weight value to the BFM6. And then we change the value of BFM7 to set. We need to show the net weight or the gross weight. As you can see it now, I put this package, empty package, to the load cell, and we get the value 41. And now we trigger M3 here. And then if we want to, sorry, it's displayed in, it should be displayed in net weight. And first we choose to display the value in gross weight. Now I put another object into it. As you can see, now the whole weight, the total weight is 290. And if I click to trigger M4 here, you can see now the value changed to 250 because it get rid of the value of just the package. With the PLC inside, we just get the net weight of the PLC. So we just to display the value we need just by change the value of BFM7 here. If I trigger M5, now the value changed back to 290 here. Okay, do you have any questions about this part? If so, we can move to the next part. Is to use BFM4 to read the state of the module. Let's wait a moment. As we can see it here, in BFM4, it shows the different states of the channel 1 and channel 2. If the state, the measured value is stable or not, or if there is 0 point weight for the different channel. As you can see now, if I put nothing, on the load cell of the channel 1, this state flag will be on. And if I put any object on the node cell, it will be 0. And when I made a change of the state, the value is unstable, it will be off for the bit 4. If I put harder here, it will be put a hand on here on the load cell, it will be off. And if the weight value is stable, it will be on. So we can use this bit flag on our PLC program. I think it will be helpful. Okay, do you have any questions about this part? About how to read the state? Here I use a K4M200 here. Is to mapping this 17 bit to from M200 to M215. It just shows the different bit. Okay, let's move to the final part of our LF3V2WT module. Is about calibration without weights. Because this load cell have some problems, it doesn't support this. I just show the state if your load cell support this function. As you can see here, there is some parameters on the load cell. The range of the weight and the character of the load. So here is 20 kilogram and 2.0 MV. So we can write this value parameter to the corresponding BFM registers. For example, this part, if the load cell range is 3 kilogram, so we set the value of D8 as 3000 and write it to the BFM 23 by trigger M10 here. And then we write the sensitivity in D40 to the BFM 39. For example, the sensitivity is 1.042 MV per volt. So we triggered M11 here to write the sensor sensitivity setting. And after that, we write K3 into the BFM8 to finish the calibrating without weights. After that, when you put the object on the load cell, you can also get the value of BFM 16. But there is something wrong with the load cell, so I didn't make this presentation here. But it works before. Okay. Do you have any questions about this LX3V2WT mode module? If you have any questions, you can leave your message in on our WhatsApp group. Let's move to the next part about LCM module. For the moment, we just have one LCM module for wiring. It's LCM 2WT. So as you can see, you have two channels to connect two load cell. And the other part is also the same to another LCM module. We have a communication terminal RX485 and the power supply terminal needs to connect DC 24 volts and the same indicators to show the state. Actually, the wiring is the same to LX3V to WT. And the same indicator lights. For the pip-off memories, this is the modbus address to set the parameters and to get the weight value. Actually, it's also the same as the LX3 weight to WT. So because this module is communicate with PLC by the Modbus protocol, so we also need to set the communication parameters. For LX5V series, you can directly set its communication parameters here. And the PLC will be the master station, so the station number of the PLC will be 0. And if you use LX3V, so you need to set these parameters by writing a value to the system special registers. So we're going to and then we need to set some parameter of the RS instruction here. So one means I set the LCM module, the station number is 1, and the 06 is the function code for write the value, and the 03 is for the read function code. And then we also need to set the data length we need to read and write. So here I use LX5V to make this introduce. Here it should be SM100 to read the wait all the time. Here it should be the same BFM 16 here. And then the length also need to be 2. The previous one is to read the state, not the weight value. And we can also to write the value of BFM 8 to set the to make the weighting calibration. It's the same process, just put nothing on the load cell, triggered M0 here, and then we put the standard weight to the load cell and write the value to the BFM 23 and write K2 to the BFM 8 to finish a calibration. And it's also the same for to set the tail weight and read the gross net weight or the net weight just by changing the value of BFM 7. Okay, do you have any questions about this LCM weighting module? Because it's very similar to the usage to the digital module, digital input and output module. So I didn't introduce the usage of DIP switch. It's also the same. The first 3 DIP switch is to set the slave station number, and the rest 5 DIP switch is for to setting boundary rates. So when you use LCM2WT, if it doesn't work properly, the first things we need to check the LED state. If it works normally, by we can judge it then by these LED indicators. And just a tip, if the load cell, the cable of the load cell is not longer long enough to meet your requirements, you can not just extend length just by some normal cable. You need some specific cable because the signal cannot transferred just by some normal copper wire. Okay, this is all about today's training. Do you have any other questions? Okay, that's all for today's training. If you have any other questions, you can leave your message in our WeChat group. See you next Monday. The training is about the program flow. And for the last things I need to mention is about the after class exercise for today's training. It's to use LCM, LX 3V or 5V to make the program to use LX 3V to WT module for, for calibration and to display the net weight. I think it's easy because I just showed all the process in today's training. So please do remember to submit your after class exercise before the final exam. If you fail to submit 2 or more times, it's not allowed to attend our final exam. And please beware of it. Okay, thank you for your attend today's training. See you next Monday. Bye bye.
Thanks for the training. Bye.
Bye.
Thank you. Thank you so much.
Thank you. Thank you for the attend today's training.